Alright, in this video, this is AP Physics. I wanted to show you how you can do the impulse lab using the data that you got from Logger Pro. The data you got from the Logger Pro should have come you should have two graphs, and these are very, very, very rough graphs. And so I just want to point them out. But you would have a distance versus time graph and a force versus time graph. With the distance versus time graph, you will get your change in momentum. With the force versus time graph, you are going to get your impulse. And the goal of this lab is to compare those two things and see if impulse does indeed equal the change in momentum. And you should have a couple trials. From the distance versus time graph, there's also a velocity versus time graph that you could have used. You should have measured the slope of the line right before and the slope of the line right after the collision. And you could have used the linear curve fit function on those, and you would have gotten two different slopes. The slope of a distance versus time graph is equal to your velocity. I'll call this the velocity before, which let me just give it a random number. Let's say it's 0.82 meters per second. Yours could have been the opposite, going down and going up, depending upon how your motion detector was set up. And let's say that for the second one, our velocity after, we'll call that v2. Let's say that was negative 0.76 meters per second or something like that. You would have then needed to measure the mass. Let's say our mass was 0.62 kilograms. Okay, you probably should have had 4 significant digits on all of these things. Okay, down here on the force versus time graph, you would have needed to use the integrate function on the Logger Pro, and it would have calculated the area of the curve right here. So the area, this is the little impulse that is given that causes this change in momentum. Okay, so the area under the curve, this is equal to your integrated force dt. It's the integration of the force with respect to time, which is our impulse. Okay? So you get two different numbers. Let's say then you would need to calculate in a data table. You have the mass of the cart. You would have the velocity before. You would have the velocity after. And you would need to get the change in momentum. Okay. And then you would also need to record the value of impulse, and what the percent error is. So maybe you use different masses for the carts, 0.62. Our velocity before we got is 0.82. That's what I just did. The velocity after was negative 0.76. So what is the change in momentum? Let me work this out. Change in momentum equals mass times change in velocity. And I could have plugged, I'm probably not in here. I did all this work if it didn't show up in the screen. Mass times change in velocity. And we could calculate what those things are. The change in velocity is your final, which is negative 0.76, minus the initial, which is positive 0.82. So our change in velocity is negative 1.58 meters per second times the mass, which was negative 977 kilograms meters per second. It's negative. So that was our change in velocity. Our impulse is what we would have gotten from the graph right here. Let's say that we measured this and the impulse turned out to be let's say it turned out to be negative 0.892, and that would be Newton seconds, force times time. The units are the same, so I'm going to record that over here, negative 0.892. And then to get the percent error, if you remember, percent error equals your measured minus your theory over your theory times 100. So we are going to treat the measured as our change in momentum and our theory as J. It's not that important which one it was, but 0.977 is what we got, negative 0.977, minus 0.892, should be minus the negative, but it's going to give you the same answer, divided by the theory, which was our J, is 0.892, gives us times 100, gives us a 9.53% error. And you would have to do that for all of your trials. So then you are trying to find the percent error and comparing. This shows that the theory didn't quite match with what it was because our percent error was above 5%. If you got below 5%, that is showing a good experiment that validates the theory.